Chandrayaan-3 mission, India's third lunar exploration mission, has achieved some remarkable feats, such as landing on the moon's south pole, performing a hop experiment on the lunar surface, and making some amazing discoveries about the moon's geology and chemistry. But what exactly does this mission mean for our understanding of the moon and its potential for future exploration and habitation? How did the Chandrayaan-3 team overcome the challenges and difficulties of landing and roving on the moon's south pole? What are some of the key findings that have been made by the Chandrayaan-3 orbiter,
video,
lander, we will answer these questions and more by looking at some of the latest news and updates about the Chandrayaan-3 mission. So stay tuned and get ready to learn more about India's amazing moon mission. The first thing we talk about is the Vikram lander's unplanned hop experiment on the moon's surface. According to the project director, Veera Muthuvel, this was a surprising and unexpected event that happened just a few hours before the lunar night began. The Vikram lander, which had successfully landed on the moon's south pole on August 23rd, along with the Pragyan rover, suddenly lifted off from its landing site and flew for about 10 seconds before landing again at a distance of about 50 meters. This was not part of the original mission plan, but rather a spontaneous decision made by the lander's onboard computer. So, what is a hop experiment, and why did the Vikram lander do it? A hop experiment is a maneuver that involves lifting off from one location on a planetary surface and landing at another location. This can be done for various reasons, such as exploring different sites, avoiding obstacles, or testing the performance of the spacecraft. In this case, according to the project director, the hop experiment was done to demonstrate the capability of the Chandrayaan-3 system to lift off from the surface of the moon, which could enable future missions to return samples from the lunar surface to India. He said that this was a bonus objective that was not planned beforehand, but rather executed by the lander's computer based on its own analysis of the situation. This experiment was a remarkable achievement for several reasons. First of all, it showed that the Vikram lander had enough fuel and power to perform such a maneuver, despite having already completed its primary mission objectives of landing and deploying the rover. Secondly, it showed that the lander had a high degree of autonomy and intelligence, as it was able to decide and execute the hop without any human intervention or communication. Thirdly, it showed that the lander had a robust navigation and guidance system, as it was able to accurately control its attitude, thrust, and trajectory during the hop. And finally, this means that the lander had a durable structure and design, as it was able to withstand the impact of landing twice on the rough and rocky terrain of the lunar south pole. Such missions would require a spacecraft that can lift off from the moon and rendezvous with an orbiter or another spacecraft in lunar orbit. So this hop experiment demonstrated that this could be further developed and refined for future missions. In fact, India has already announced its plans to launch Chandrayaan-4 in 2026, which will be a sample return mission that will collect rocks and soil from different locations on the moon and bring them back to Earth for analysis. Let's start with what happened to Luna 25 on August 19, 2023. Luna 25 was launched on August 11, 2023, from the Baikonur Cosmodrome in Kazakhstan aboard a Soyuz 2.1B rocket. The mission was designed to land on the south pole of the moon, near the Boguslavsky crater, where there is evidence of water ice and other volatiles. The lander was equipped with a suite of instruments, including a camera, a spectrometer, a seismometer, a magnetometer, a laser retroreflector, and a drill. The main goals of the mission were to study the lunar regolith, soil, the thermal and radiation environment, and the magnetic field of the moon. The landing was scheduled for August 19, 2023 at around 10:30 UTC. The lander performed a series of maneuvers to reduce its speed and altitude as it approached the lunar surface. It used 4 main engines and 8 attitude control thrusters to control its orientation and trajectory. Everything seemed to be going well until the final seconds before the touchdown. According to Roscosmos, Russia's Federal Space Agency, an onboard control unit failed to turn off the engines at the right time because it did not receive the necessary data from one of its accelerometers. An accelerometer is a device that measures acceleration or deceleration. In this case, it was supposed to detect when Luna 25 reached 0 vertical velocity, meaning that it had landed softly on the moon. But for some unknown reason, the accelerometer did not send this signal to the control unit, which kept firing the engines until they ran out of fuel. As a result, Luna 25 crashed into the lunar surface at a speed of about 50 meters per second, or 180 kilometers per hour, creating a large crater and scattering debris over a wide area. The crash was detected by NASA's Lunar Reconnaissance Orbiter, LRO, which orbits the moon and takes high-resolution images of its surface. LRO spotted the crash site near the Boguslavsky crater and compared it with previous images taken before the landing attempt. The images showed a bright spot surrounded by dark ejecta, material thrown out by the impact, indicating that Luna 25 had hit the moon hard and exposed fresh material from below. NASA's orbiter also detected a faint plume of dust rising from the crash site, which lasted for about an hour after the impact. The failure of Luna 25 was a major disappointment for Russia and its space program. It was supposed to be a milestone in Russia's return to the moon after decades of absence. It also supposed to be a precursor for more ambitious missions, such as Luna 26, an orbiter, Luna 27, a lander with a rover, and Luna 28, a sample return mission. But instead of celebrating a successful landing, Russia had to face a humiliating setback and a loss of prestige. So what caused Luna 25 to crash into the moon? What went wrong with its onboard control unit and its accelerometer? And how difficult is it to land on the moon anyway? These are some of the questions we will address in the next section. Please give it a thumbs up and subscribe to our channel for more videos like this. And don't forget to hit the bell icon to get notified when we upload new videos. Thank you for watching and see you next time.